Welcome to the first episode of UnaSimulator Video Series. My name is Emre, and this video series will be about simulations involving military systems, tactics and strategies, and also some business analysis and physical systems. So what is UnaSimulator? Well, UnaSimulator is a generic Monte Carlo simulator software. As you can see, it has a very simple, maybe stupidly simple, graphical user interface. But the code and algorithm behind it are not so simple. It actually has a very advanced stochastic probabilistic simulator algorithm with Monte Carlo method and statistical analysis. So the overall architecture can be outlined like this. The simulation actually runs repeatedly over and over with an outer scenario loop, and inside that scenario loop there's an inner time loop in which the time is incremented so that the calculations are done in a time-based fashion. The parameters and variables in those calculations are used for real-time visualization, as well as the evaluation of the results or the outcomes for each cycle. After a certain number of repeated simulations, the final results are evaluated and compiled in terms of probabilities and distributions of the outcomes. So, having said that, we can again look at the user interface of UnaSimulator. The very simple controls are located on the right. Those controls add the predefined objects into the simulation, choose the parameters to be monitored, and setting up the number of cycles, number of visualized cycles, total time for each cycle, and visualization time steps. Of course, it has extensive modules for creation of objects, defining behaviors of those objects, creating environments and laws, etc. But we'll get to those later. With all these features, UnaSimulator can be used in many different applications, such as military analysis. CONOPS, which is short for Concepts of Operations, is very important. Before the development of any defense industry product, the requirements are generally set after this CONOPS analysis. Survivability analysis is also very crucial, especially for the military vehicles. And most importantly, UnaSimulator is a great software for wargaming, and the reason is actually the theme of this episode. For business analysis, UnaSimulator has its uses during the business planning with simulation. The probabilistic calculations can be used in sales forecast, as well as risk analysis. Being a generic multifunctional simulation framework, UnaSimulator also handles the simulation of physical systems, probability calculations, and statistical analysis. In this video series, all those aspects are planned to be covered by lots of real-life examples and applications. So, this is the first episode: Military Simulations and Monte Carlo Method. The objective of this episode is the introduction of Monte Carlo method and discussion about its use in military simulations. In this episode, a very simple situation will be simulated. This example involves a tank, an area, and a scoreboard. The tank is a hypothetical tank that shoots randomly into a square with 1 km to 1 km dimensions. The area is that 1 km to 1 km square area plus a circular area with a 1 km of diameter just inside the previous square that the tank shoots at. And finally, there is a scoreboard, which shows some parameters in real time. The number of shots, the number of shots that land inside the circle, the ratio of above two numbers, and above ratio times 4. So the scenario is very simple. Tank shoots, scoreboard counts, and that's it. Let's start the simulation. First, we need to add the predefined objects. Well, how to create those objects, how to set their parameters, and how to set their behaviors will be covered in later videos. This is our tank, and this is the scoreboard. Okay, there's no need to enter the monitored parameters because our scoreboard already displays the values in real time. So let's run the simulation 100 times and make them all visualized. So we will see all the cycles in real time. Let's set the total time 6 seconds and time step 1 second. So we are ready to go. Let's start. Okay, you can see the parameters changing. Well, the reason why we are displaying those values and their meaning, we'll come to that shortly. Maybe some of you may already figured out where this is going. So let's wait until it's finished. So here's the parameters. Okay. Now let's repeat the simulation again. Now running the simulation. I don't know, 2000 times. Let's add the tank. Let's add the scoreboard. Yep. Now let's set the number of cycles 2000 and make just first 10 of them visualized, because there's no need to see all these cycles. So you can see the numbers are not updated. The simulation is running on the background, but we are not seeing all the cycles because there's no need for that. Now the simulation is running 2000 times. And the results will be shown shortly. Yep, that's it. Well, as you can see, all the shots covered the area like a carpet. 2000 shots. And you can see the results. You can see this result. Does it look familiar? Yeah, it is very close to a certain number, right? The pi number. If we run the simulation, I don't know, 10,000 times, it will be more similar to pi number. Let's try it. Okay, right now we will run the simulation, I don't know, 10,000 times. Let's add the tank. Let's add the scoreboard. Now let's enter 10,000. Just first 10 to be visualized. So let's start. Now we're gonna wait a little bit. So here we go. As you can see, the shots are distributed more uniformly, and the number resembles much like the pi number. Well, the explanation is simple. As I said, the points that the tank shells landed make up an area, a square area, and a circular area. As the number of points increases, the point cloud becomes more and more similar to an area. And the area of the square is simple, just d square. And the area of the circle is pi times d square divided by 4. So when we take a ratio of these areas and multiply with 4, we got the pi number. And since the number of points in these areas can be total areas, provided that there are sufficient number of points, of course, it's possible to write this equation too. So you can ask why this is the case. Isn't there a possibility in which none of the shots lands in that circular area and that number becomes 0? Well, theoretically, yes, there's a possibility, but practically, no. I have never seen such a result, and I don't think I ever will. Why I'm so confident? The reason is the law of large numbers. Well, it says if you repeat some random event a lot, the results are going to converge to an expected value. And in real life, it is always the case. The most famous example is the diffusion problem and the behavior of gas molecules in total. Although each gas molecule moves randomly and theoretically speaking, there's a chance that all molecules decide to go into a single direction, hence creating a vacuum on the other direction all by themselves, well, that just never happens. Diffusion occurs very deterministically and there is no randomness at all because of the large number of molecules. Very, very interesting. And Monte Carlo method is actually based on this phenomenon. It's about repeating the event over and over and over and then investigating the results and get the probabilities in a numerical fashion. UnaSimulator also uses this method so that probabilities of complex situations can be calculated with ease. One of the uses of this method is military wargaming. Throughout the history of humankind, military wargames are always performed. But the problem with these wargames is they produce one outcome per game. The result can be one thing, which might depend on other things, but there's no such outcome like, okay, this is the result, this is the outcome, but it happens with this probability, and this is the another outcome with this percent probability, etc. I mean, to get some kind of probability of the results, the game should be restarted and many times. And with the computer technology, it is quite possible to run the scenario thousands of times, even millions, and the result you get converges to a certain value thanks to the law of large numbers and Monte Carlo method. So this method also enables us to calculate certain probabilities, which are actually impossible to calculate by analytical means. So what we get from UnaSimulator or Monte Carlo simulators in general is the thousands of cycles, thousands of outcomes, and their probabilistic analysis. So this is the main advantage of UnaSimulator, because it gives you not a single result, but thousands of results and their probabilities. You can even add such probabilities in the behaviors of the systems in the simulator. We will get to that when we run more practical scenarios in the upcoming videos. Until then, thank you very much for watching. Have a nice day and see you in the next video.